Today we will study displacement current. This one, these two are parallel plates, circular plates of parallel plate capacitor. This one is having very long wire. Here we have connected a battery. So during charging, applying ampere circuit law to the loop. This one is imaginary loop. Applying integral B dot dl equal to mu naught sigma IC, algebraic sum of electric current passing through the loop. But there is no conduction current, so it is 0. So integral B dl cos 0 is 0. But practically here, magnetic field is there along the periphery of the circle. So angle between B and dl is 0. So integral B integral dl is 0. So B into 2 pi r is the radius of this circular loop. So B is 0, which is contradictory because of practically magnetic field is there. So something is wrong with this equation. But during charging of a capacitor, B is there and it is same as the B due to infinite long wire. So something is wrong with above result. Maxwell corrected it by introducing displacement current, another term. So this equation is modified by Maxwell. Line integration of magnetic field over closed loop is mu naught sigma IC plus mu naught E naught into d phi E by dt, rate of change of electric flux. So integral B dl cos 0, applying this rule to this loop. There is no conduction current passing through the loop. So it is 0, but mu naught E naught into d dt of electric flux is E dot A. So mu naught E naught is d dt of electric flux EA cos 0, because of during charging electric field increases. Mu naught E naught into d dt of E is sigma by epsilon naught. We know that electric field between two plates is sigma by epsilon. Sigma is surface density. This is area of the plate. So mu naught E naught into d dt of sigma is replaced by Q by A. So A cut out, Q by epsilon. Epsilon cut out. So B into 2 pi r is mu naught into dq by dt. So mu naught id. So this term is known as displacement current, E naught into d phi E by dt. From this we conclude that not only conduction current, the changing electric field also creates magnetic field. Now another topic, intensity of parallel light beam. Suppose highly parallel light beam is there, having area of cross section in vacuum. So in time delta t interval, light energy crosses covered this much of distance. It is C delta t. So whatever the energy crosses this cross section in time interval delta t, it is accumulated in this cylinder, this one. So intensity I is energy upon area into time. So AC delta T into rho A delta T. So rho C. In 1 cubic meter rho joule energy. So AC delta T cubic meter, how much energy? AC delta T rho. A cut out, delta T delta cut out. So rho C. So intensity I is given by, here rho is replaced by, the total intensity is rho E plus rho C. Rho B. This one is B, rho B. Energy corresponding to electric field. Energy corresponding to magnetic field. So half epsilon d square plus half b square by mu naught. But we know that half b square by mu naught is half epsilon naught ERMS square. So rho is rho E plus rho B, or it is epsilon naught ERMS square. So rho is replaced by epsilon naught ERMS square into C. So when light beam falls on perfectly absorbing surface, the force exerted on the surface, it will exert force also. So according to Newton's law, delta P by delta T, but here E is m into C square, so m into C into C, so m into C is U by C. Suppose the surface is perfectly absorber, so initial momentum is m into C and final is 0. So change in momentum is m into C, delta T is 1 second. We have taken light energy of mass m incident in 1 second. So mc is U by C. So it will exert a force U by C. If the surface is perfectly reflector, F is this one is mc and this one is minus mc. So change in momentum is 2 mc. by 1 second, so 2u by c.